In this KORNCAST, we're going to learn how to graph quadratic equations the easy way by using the parent graph. Our new parent graph is going to be f of x equals x squared, which is our quadratic equation. Well, let's go ahead and take a look at a table to graph this equation. Pick our standard 5 points, -2, -1, 0, 1, and 2. Well, -2 squared is 4, so our first order pair is going to be -2, 4. -1 squared is 1, so our order pair is going to be -1, 1. 0 squared is going to be 0, so 0, 0. Next, 1 squared, which is 1. So our order pair is 1, 1. And lastly, 2 squared, which is 4, and so we get 2, 4 for our last order pair. Now we could pick values. For example, we could pick 3 and get 3 squared, which is 9. And we could plot that as well, but I think once we get the hang of our symmetry, which we have in our ordered pairs, that's probably good enough. And once we get our ordered pairs, now we can go ahead and plot our points. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now please note that when graphing quadratic equations, we're going to want to have these 5 points. Now let's draw our familiar U shape. And that's the graph of our new parent function. Now let's recall some important information from Algebra 1 about quadratic graphs. And the first thing is the vertex. The vertex is the point on our graph where the graph stops going down and starts to go up. And in this case, 0, 0. Now the next important piece of information is our line of symmetry. The line of symmetry, if you recall, has to go through the vertex, and it basically separates the graph into 2 equal pieces. And a nice way of thinking about that is if we decided to fold our graph down our line of symmetry, we would get the same part of the graph on each side. And also note that the distances from the line of symmetry to our points on our graph are the same distance. So the equation of our line of symmetry, in this case, is going to be x equals 0. And please note that that's the same value that we have on our ordered pair for the vertex x value of 0. The last piece of information I want to take a look at is the domain and range. Now if you recall, the domain are all x values of our graph. So since our graph is going up and to the right, as well as up and to the left and everything in between, our domain is going to be all x values, or -infinity to +infinity. If you recall, our range are all y values of our graph. So our range is going to be all positive values for y, including 0. Or in our interval notation, we include 0 and we go to +infinity. And that's our new parent graph. Now it's time to investigate. Please get out your calculator and set it to the double decimal window. If you don't remember the easy way to do it, just type in these values for your x-min, x-max, y-min, and y-max. In this investigation, I want you to use your graphing calculator to graph the following equations. I want you to draw a sketch in your notes. And lastly, I want you to write down some observations on what is happening to the graph. Please press pause till done. Now it's time to summarize your observations. What happened to our parent graph when A did the following? Take a moment and write down your observations now. Please press pause till done. Well, what happened to our graph when our A value was greater than 1? For example, what if our A was 4? Or if our A was, let's say, 1.5? What happened to our graph? Well, this is our vertical stretch. What happened to our graph when our A was bigger than 0 but less than 1? Let's say a value like 1/2, or an A value of 0.02. Well, this one was a vertical compression. What happened to our graph when our A value was less than -1? For example, let's say our A value was -5, or our A value was -1.2. Well, we would get a vertical stretch and a reflection. And finally, what happened to our parent graph when our A value is greater than -1 and less than 0? For example, an A value of -1/3 or an A value of -0.001. Well, we'd get a reflection and a vertical compression. Now it's time for our next investigation. Like before, let's use our graphing calculator to graph the following equations. Draw a sketch in your notes. And finally, write down your observations on what is happening to the following graphs. Please press pause till done. Now it's time to summarize your observations. Please explain the difference between y equals a times x squared and the following equations. Please press pause till done. Now an example of this first equation would be y equals x squared plus 2. So what happens to our graph when we add a value to our squared term? Well, you probably noticed that it would shift our graph up 2. So we would get a vertical shift up, whatever that k value is. An example of the last equation, let's say y equals x squared minus 3. Well, you probably noticed that it would shift our graph down 3. So we would get a vertical shift down, whatever that k value is. And now for our final investigation. As in our other investigations, use your graphing calculator to graph the following. Please draw a sketch in your notes, and finally, write down your observation on what is happening to the graphs. Please press pause till done. Please summarize your observations now by explaining the difference between our parent graph and the following. Please press pause till done. An example of this first equation would be y equals x minus 1 quantity squared. Well, you probably noticed something interesting happening here. If we graph this, you'd probably notice that the graph got shifted to the right one. So when we have an equation in this form right here, we're going to get a horizontal shift right, whatever that h value is. In our second equation, an example could be y equals x plus 5 squared. Now, if you recall from your observation, if we had a positive 5 in here, it would shift our graph to the left. So we would get a horizontal shift left, whatever that h value is. Now, if we rewrite our quadratic equations in this form right here, we can utilize our knowledge of our transformations to get our vertex. Now, because we know we shift our parent graph to the left or right, and we can also shift our graph up or down, we know that our vertex must shift along with our parent graph. And because of our knowledge of those shifts, our vertex is going to be hk. Because in this case we have a negative h, we change the sign, and there's going to be our horizontal shift left or right. We're going to shift our graph up or down, and if it's positive, we're going to shift it up. So our y value is going to be our k. So it is quite easy to look at this form of our quadratic equation right here to get our vertex. And that's why we call it the vertex form of our quadratic equation. And now the only thing we have to contend with is what our a value is and how it affects our graph. And that's what we're going to take a look at next. Please proceed to the Graphing Quadratic Equations Examples KORNCAST.